the sound and how the sound is produced, right? And in order to do a sound, for example, let us take the birds, right? The birds will be doing some musical sounds, right? Hymnings, like every bird will be doing one type of sounds, right? And it is familiar for that. In the same way, we will be seeing different types of sounds in our environment. Like, let us see, when we stample a stick like this, the sound what we are getting is different. When we take a pen, right, it will be different. When we stample on the board, right, it will be different. That means the sound is generated in accordance to the production of our energy. That means how much we are spending. That means, do you know that in order to do a sound, we are consuming some energy, or we are producing, or when we are releasing our efforts. That means we are doing some work in order to do a sound. For example, let us take what I am speaking, right? What I have spoken, for that I am consuming my energy, right? Therefore, I am getting the result, that is my sound. In the same manner, sound, in order to do any sound, we have to use some energy, we have to do some work, right? That is the definition of sound here goes like that. Sound is a form of energy which produces a sensation of hearing in our ears. That means whenever we hear something, we will be realizing that some sounds came, right? Fire engine sound, that is right, we will be seeing. And 101 hospital ambulance sound on the roads while we are going. All these sounds, there will be different sounds in order to recognize that something is for a particular purpose. One sound is related to one particular purpose, right? And at the same time, the difference between the crow, right, and the parrot, and the way they sing, the way they talk, that is, by that we will be concluding or differentiate between the words, right, between the persons. When we hear them on the phone, we will be guessing who is that person by hearing their voice, right? That means in order to do a sound, or in order to perform a task like sound, we are consuming our energy, and that sound will be passed in the medium, that is in the air, and it will reach to our ears, and thus we will be hearing the sound. Now let us see in this chapter how the sound is produced and how the sound is transferred in this medium in order to reach our ear. And at the same time, we will be seeing the different types of energy, right? There we have seen already the different types of energy, like such as mechanical energy, chemical energy, heat energy, like solar energy, natural resource, the sun. And also we have seen the conservation of energy, that is the principle of conservation of energy. That is, energy is neither created nor destroyed, right? It is just transformed from one place to another place. That means heat energy is transformed from a boiling water. From boiling water, it is transferred to the utensil in which it is boiled, right? And at the same time, when you keep a boiled cup of milk in a cool water, the heat will be transferred to the cold water, right? And the milk will be lessened now, the temperature will be lowered, right? At the same time, that means the heat is transferred from the milk to the cold water. In the same way, the energy or the heat energy or any energy, chemical energy or kinetic energy, whatever energy, it will be transmitted from one thing to other, right? That is the conservation of energy. Now, for example, let us do one activity, simple activity, in order to understand about the sound concept, right? When we clap, right, the sound is generated, right? That is going into our ears, and we are able to hear the sound of the claps, right? And at the same time, what is the energy, right? Previously I have said to do a sound, we are consuming some energy, right? Sound is a form of energy, I am saying. Then in order to clap, I have done some work. I have spent my energy, right? What energy I have spent for sound? In order to generate some sound, what energy I have used? What type of energy is used in sound? Let us discuss that. And also, what is the reason for the production of sound? And what are the causes of the sound? And how the sound is transferred in the medium? And how the sound is heard by our ears? and how the sound is generated. All these topics, let us discuss them in detail in this topic, and let us know what are the causes and reasons for the generation of sound and for the production of sound, right? Previously we have seen that sound needs a medium to travel, right? That is, sound travels in a medium such as air, water, steel and so on, and it cannot travel in vacuum, right? We have seen that in experiment practically. Now let us see how the sound waves are travelled in a longitudinal way, that is in a horizontal direction in which the waves are generated. That is, for example, let us take one spring or slicey, that is as shown in the figure. When you compress it or when you expand it, you will be seeing that at some stage there will be a compression and some stage it will be like relaxation, right? That is, the compression of the string wires, you can observe that here. This stage is known as the compression stage of the slicey or string, and at the same time when they come into their rest position, it is known as rarefaction, right? That is the second stage or original state of the strings. These two stages will be occurring because in order to travel the sound in the air or any medium. Now let us see how the sound waves are travelled in the longitudinal way. That is, if at all there is any vibration or any disturbance or any compression during the starting position, that will be affected in the horizontal direction only for the remaining particles which are nearer to the spring. That means the other particles are also exhibiting the same compressive state or displacement in the same direction of the first ones. So we can say that they are expressing or they are under the pressure or force or compression of in longitudinal direction only. At the same time we can say these as the longitudinal waves, and we can give the best examples such as water, right? When there is a disturbance in the water particles, right, they will be attaining a wave shape, right? That is, the longitudinal waves are arised. That is, the disturbances occurred in the first starting position will reflect the other particles nearer to it in the same manner only. So we can say them as the longitudinal waves, right? And there are another type of waves that are known as transverse waves. That is, the particles do not oscillate along the line of wave propagation. That means here the particles are disturbing the rested particles beside them and they are attaining the same displacement in the same direction, that is through the line of propagation, that is the straight line propagation, right? And at the same time, for the transverse waves, for example, we can take light waves, right? Light waves are known as transverse waves because the direction, when the light ray is reflected or transmitted in the medium, it is reflected back or it is travelled in the perpendicular direction of the propagation of light. That is, we can say such as, see, it reflects to the medium or the, right, what we have taken, that is base, and it is reflected back, that is known as the reflection of light, right? And the movement of these waves will be perpendicular to the propagation, that is to the origin of the disturbances occurred in the medium, right? And at the same time we can differentiate by using the how it is transformed. That is, if it is in horizontal direction, then it is said to be longitudinal waves, and if it is in a perpendicular direction, then it is said to be as transverse waves. Let us see the definition here. That is, individual particles of the medium move in a direction parallel to the direction of the propagation of the disturbance or anything, right? If they are moving in a parallel to the disturbance, then it is said to be longitudinal, and if it is at all in perpendicular, then it is said to be as transverse. But previously we have seen, due to any force or pressure, the particles will be undergone into a vibration, right? But in light waves, there is of a medium, and at the same time there is no change in the pressure or density, right? And there is no compression also. And we will see in more or in detail about the transverse waves in higher classes. Factors that are affecting for the sound, that is the causes of the sound, that is frequency, amplitude and speed, right? But now let us see how they are represented or how they are calculated with respect to the sound wave which we are represented in a graphical form, right? Now let us see that. For example, let us take any drum. If you beat or if you strike anything and if you generate any sound, right, it will be having 2 points, right? That is the maximum point and the minimum point. Suppose if you take a pendulum, right, which is tied to a stick with the help of a thread. If you pull the pendulum to the corner of the one side and if you leave it, then it will be flowing from one end to the other end, right? Like this it will be flowing, right, from here to here, right? It will be passing on, right? The to and fro motion of this ball, right, ball or pendulum will be resulting in to and fro motion, that is forward and backward direction, right? And at the same time we can say that this is the minimum point or the zero rest point. Let us observe that, and it is moving from here to the maximum point, right? If at all we take this is as a rest position, then it will be moving from decreasing point to highest point, that is minimum point to maximum point, right? So for everything we will be having 2 points, that is the maximum point and the minimum point, right? Therefore we can say that the density of a substance or a ball or anything mass, right, that will be oscillating between the maximum and minimum values, right? Then we can say that the frequency of a particular substance will be related to the density, because how much energy you produce or you keep regarding to produce a sound, that much amount of density or that much amount of sound is generated, right, for that particular density of an object.